Matthew, have you looked at the Tuts for You IDA tutorials, and would you recommend those for kind of further practice?
I am aware of them. I've never used them, so that I could not tell you. I've used crackmes.de.
Didn't that site get taken down?
Probably. I'm not surprised.
Because I was trying to pull stuff down from, yeah, Zeno says it. So.
That's still down. There are some interesting examples there. So one of them was called Hyper Unpack Me 2, and it essentially was its own bytecode interpreter. So it basically they took a program, they ran it through this byte-coded. It created bytecode so it translated x86 assembly into this new language, and then it inserted an interpreter into the executable. And so when you took a look at the thing, it was just this big loop, and it would read a byte, and then it would decide, does it want to execute something? So there's this big switch case statement, and it would decide what commands to run based on the byte that it read. So it was not RISC, it was CISC. So you probably wouldn't like it.
Yeah, use what works.
But it was, so a very interesting way of obfuscating the meaning of an executable, because none of the code is natively ever available in x86. So it's not as if it decodes it into place and then runs it. It actually says, well, this opcode means that we should perform an OR and set these flags. So it had its own registers, like there were variables that acted as registers. It had its own stack. It had flag registers. It was definitely very challenging.
Zeno says he has a mirror of all the files.
Aha! Is that available, Zeno? Okay. So Zeno's saying he's going to put some of the crackmes stuff in his transfer folder. So keep an eye out for that. They're really interesting little reverse engineering puzzles. Recommend checking them out.
I just googled crackmes. There's also some mirrors as well. It's the third one down. It says malware reversing.
So apparently Zeno said some of these are detected by whatever security products you guys are using. Yeah, some of it will flag uneven.
Yep, I've done that a few times. Had to go off, get an email a couple hours later. Reed, we found 17 viruses on it? Yeah.
I put the DEF CON CDs in my computer at work. That lasted
So
about 10 minutes.
it looks like we're ready to go here. All right, so we ready?
In case you're wondering, give this guy that flashlight.
So how many of you have ever written an object-oriented program? Pretty much everybody. All right. How many of you have used C++? Okay. Kind of, sort of. All right. So we're going to talk a little bit about object-oriented code and how, okay, no C++. All right, that's okay. So we're going to talk about object-oriented code and how it might look if you're looking at some code compiled using it. So I'm going to talk about ways of identifying that something might potentially be using classes and structures that define functionality, and talk a little bit about inheritance and what that will look like as well. So when you have an object and it has member functions, it has what's called a this pointer, okay? And this pointer is essentially, it says, this is where the base of the object is. So yesterday I showed you, I wrote a struct up here called person. So let's say we created a person object, all right? So this would point to the beginning of it. All right, and then I said it had a name, okay? And name was 128 bytes. And then I said it's got an age. So that's at byte 132. That ends at byte 132. And then maybe it has pointer to another person. Let's say a spouse. Okay. So this refers to the beginning of the object. Now, if for some reason this thing had used inheritance, the first thing it have is a B table, a VF table, or a V table. This is basically just a pointer to some other memory. Which then contains a function.
So the V table is a pointer to a list of functions.
Yes, it's a pointer to a list of functions. So when you have inheritance, you say maybe, okay, for the person object, maybe they have maybe a function is move, okay, and then you've got let's say you have a runner, okay. So a runner would be a specific kind of person. Maybe their move function would move them quicker than the standard person. Okay. So that's the idea of inheritance. And so this virtual function table will have the different addresses of the functions that a particular object would use. Okay. So. And we'll come to that soon, but right now, what I want to focus on is this pointer. So that says this is where my object begins in memory. Okay. So I've got some details in here about different compilers. So different compilers use different registers as a convention, but generally. What you're going to find is ECX is used as the this pointer very frequently. So what happens is we talked yesterday about there are different calling conventions, and generally you're going to see standard call, which is a bunch of pushes followed by a call. In this case, we've got this move instruction, moving some variable into ECX. Okay. And then immediately after that, we call something. Now, you might see some push instructions in between here. And if we move something into ECX and then we push ECX, chances are it's not to this call, although it is possible. You might pass an object to its own functions. It's kind of weird. But generally, you're going to see this ECX is assigned before the call, and then once you get into the function, you'll see right here, ECX is moved into this var4. So this is setting up a pointer for within this function. So every time that we want to reference the object itself, it's contained in var4. So right here we've got var4 moving into EAX, and then we do some offset from EAX. So C, so 12 bytes into EAX. So that would be, in our case here, it'd be getting something in the middle of the name. Okay. So any questions about this pointer? Okay. So we're going to do an example that'll make this a little more clear. And you'll see a lot more instances of this behavior where you have this move and then a call. So object member access, I was just talking about how once inside a member function, you'll see I've renamed var4 or whatever it will happen to be in this function to this. Okay, now I can see every place that this pointer is used. And here we have a bunch of accesses to members. So move this to EAX, and then I get the first item. So the item at position 0 in the object. Then I take the object again, and take the element at offset 4. So when you see a lot of these accesses to different offsets from any particular pointer, like we have here, then there's a high likelihood that we're dealing with some sort of either structure access or class access. Okay. So, and the difference between structure and class access, by the way, is that within structures you don't actually have public and private members, and so public members are basically things that can be accessed from outside member functions. So a class has a bunch of functions associated with it, and then the main program itself, which uses the class, might actually want to access something within an object. So if I want to manipulate, let's say we have a desk as an object, okay? Or how about, how about a person object? We'll just stick with the person object. So if Matt over here, he has some private and some public members or attributes, right? Some things he doesn't want me to access, and some things he doesn't mind. So private members are going to be things that only he wants to have access to, and public, or for that matter, only he can have access to. So I can't read his thoughts.
Bank account.
Only he can read his thoughts. But publicly accessible, I can see what color his shirt is. Okay. You don't want to share that with me? I'm going to say I won't do anything wrong with it. Okay, so another thing that you're going to see is a constructor. Okay. So constructor is, I want to create a new person, a new object of some type, and I want to set up its, I want to initialize its member object, member attributes. Okay. So right here, I've got this call to new person. I'm setting something to 72, 280, non-safety inspector. So Safety inspector, it's a person. It might be, for instance, a profession, right? So what this is going to look like in assembly is, first of all, when you create any sort of object, you have to allocate space for it. Okay, so I have to actually create this memory to put my information in. I need somewhere to store the attributes of the object. Now, this would be a dynamic allocation. So in C, you have right there, I create a pointer to a person, and then the new operator here will actually give me memory. So this is the new operator, and this is the common way that IDA defines the new operator. This is the function name, and it puts a nice little comment here that tells you it's the new operator. So before the call to the new operator, this push, that's actually going to be the size of your object. Okay. So when you go into IDA and try to create a structure, you'll actually try to define something that's 16 bytes or 10 bytes. Okay. And then what you see down here is we're comparing this var10, which we're getting from the new operator. EAX is the return value. So it goes into var10, and then we're comparing that with 0. If it doesn't succeed, or it returns a null pointer, then we're going to come over to here. If it returns any pointer to an object, it's going to come over to this side. And here we see we're taking some local variable, we're putting it into EX, and we're pushing it. Another push. So this thing, whatever this object is, it has two variables that I want to initialize, two attributes I want to initialize, and then we see the move ECX into we're getting this pointer into ECX, and then we're going to call the number function. And that is the actual code that you would write to say, okay, assign the age, assign the profession, and then it goes on to do whatever you want to do.
Is that call statement then basically a call to mmap?
Yeah. Well, I mean, it depends on the implementation, but you can think of it that way. Right. It's gonna malloc or whatever allocation function that your operating system uses, or that your compiler uses rather. So we have the ability to create this memory space for an object. We also may want to get rid of it. So object isn't needed anymore. Person died in your game, so you can kill off the person. So we're going to delete him from memory. So right here you'll see a call to delete, and it's preceded by this call up here. So this call is actually where I'm going to free up some, maybe the name I allocated on the fly. So in my constructor, I said, okay, the name is 12 characters, so I'm going to give it 13 characters of space, including the null character. Here I would do that work of cleaning up after the object, and then this is deleting the object's memory space. So now we're giving that memory back to the computer, so we can go ahead and do something else with it. Then we have virtual function tables. So here we have two different classes. We've got the person, and we've got a novelist. Okay. And so in general, let's just say a person moves boxes. So we're going to print move, whatever the person's name is, it moves boxes, or they move boxes. But if you're a specific kind of person, if you're a writer, then your job is writing books. So here we define a person. We have a pointer to a person, and we're going to create a new novelist. So I want to be able to just access, I want to work with my people, my person objects, in a very generic way. So every time I want them to do some work, I just want to call this work function rather than call the write function, the write book function, or the move box function. So here we say create a new person pointer, okay? And it's going to be backed up by data that's actually a novelist. And then we're going to have that writer do some work. So Geoffrey Chaucer writes a book. So again, we have initialization code. We got our call to our constructor. Okay, we're passing in a name, and this is the call to the code that we wrote for the constructor. And then what we have down here is we've got this access to this virtual function table. So you'll see right here we have EAX is called. Well, where does EAX come from? EAX is the first item in this. It's this item pointed to by EDX. EDX comes from ECX. Trace that back up. So var4 is actually out of this pointer. Okay. So store this pointer into ECX. Then I'm going to take the first value there. So I'm going to get this value right here. It's the address of the virtual function table. So now that I've got that address, I'm going to access the value stored at that location. So I'm going to dereference that virtual function table address. And that's going to give me the top item on the virtual function table. So you can see the organization to memory here. Got the table. It points to this list, and the first item on the list is the work function. So any questions about that?
Why is the size of 56, or was it 38x? So it's 50 for the name, 4 for the pointer, virtual table pointer?
Okay, so 4 bytes of that are for the table.
Yep.
Okay, so it's just a pointer. So it's just going to be 4 bytes, 8 bytes if you're using 64-bit. And then the rest probably store the name.
So 50 bytes for the name, 4 for the pointer. So that's 54, but the size of the struct is 56.
We've got 48 and, all right, so we've got 56 bytes.
And deword line.
Yeah.
Okay, got it.
So the number, so we can surmise that there's some space for the name because the name is passed in here. Just because the name is passed in doesn't mean that it's actually, anything's done with it, but assuming that we actually do store that, you might guess that yes, we have 4 bytes for the virtual function pointer and then another 52 bytes for the name, but maybe there are other members that we don't actually initialize. Okay, so something to keep in mind. So when you're defining a structure, you can start out, loosely. You can say, okay, I know it's this size, and there's some sort of array stored. The last thing I've found in the memory space. The bottommost thing I found is some sort of an array, so it must run to the end. Later on, some code might break that assumption. Okay. So,
How does the vtable call change if you're like dynamically casting it as you're calling the work function?
I'm sorry, can you ask that?
If you cast the object in the same line as you're calling the work function, does the vtable call change that kind of assembly signature?
Okay, so you're asking,
I declare it not as a novelist, but just as I declare Chaucer as a person object. And then right when I call work, I do a cast to novelist.
okay, so what's going to happen there is, so if you cast it
It
as
shouldn't matter.
person,
Whether it's a
it's
novelist
still-
or a person, it's always going
yeah.
to call the novelist version of work.
Well, it's really going to go to the same table for the same object,
Yeah.
no matter
Yeah.
what. The typing is just an artifact of the compiler, right?
Right. Exactly. So yeah, because this is all handled at the compiler level, you're still going to call the same work function. So right, it is. So the question is it possible to call the parent object's version of the function? Is that?
Well, I mean, you can always call the parents version, but if you create a generic base class, at least in C++, you still have the ability to dynamically cast and call subclass methods
Right.
in line. So does the vtable lookup act
Right, but that's
differently?
only for functions that aren't overridden. Okay, so if the child chooses not to override the function of the base class, then it will call the base class, and that will actually be contained in this function table. So what the compiler does is when it goes through, when it compiles a child object, it starts building up this table and says, does the child override the parent? If it does, stick its pointer in here. Otherwise, get the parent's function pointer and store that in the table. Okay. So
is the setup of the vtable getting done during the new? What's hiding inside the new operator?
So
Because it allocates memory but it sets the vtable.
the new operator doesn't do that. So talked about how we call the new operator and then we call this function here. So this function is the constructor.
Mm.
This is actually the code that would be defined right here. Okay, so this is a constructor. And what this does is just it does a string copy from whatever that input pointer is to the actual member variable name, which you see up at the top. It's char 50 right here.
Who's
But-
the vtable?
The compiler adds in the code to actually store the virtual function pointer table address. So that's something, despite the fact that you didn't actually write it into here, that's handled by the compiler and it inserts that code.
That inserted into the constructor, or?
Right. Yeah. Okay, so we've got here this struct introduction executable. Does everybody have that?
Can we do this on the Win7? Or do we need to be in the VMs again?
This one, so the only reason why we did that, and we can come back to that at the end of the day, why it is that I asked you to use Windows XP instead of Windows 7. But the reason for that was to do with how I was getting the API function. So when I was having the thing load up, load resource, find resource A, all those functions, that was done in a way that Windows 7 broke.
Okay.
No, it's just a slight modification. In fact, one instruction could be inserted in that code to fix it so that it would work properly. But if you're interested in that, at the end of the day, I can walk through it, and it will give you a little insight as to how Windows 7 changed. Okay. So everybody have struct introduction.exe? That was located in labs.zip. So if I run this, just like everything else, it doesn't do anything. Actually, it does something, but it goes away quickly. So I'm going to run it from command line. And you can see Homer is 38 years old and is married to Marge. Marge is 37 years old and is married to Homer. All right.
You say this and the kid's age is wrong.
What's that?
Yeah, the kid's age is wrong.
Zeno pointed this out. I know who the avid Simpsons fans are when I put this up here, so I leave it in there like that.
Nerd detector.
All right. So let's see here. What I'd like you to do is go ahead and just play around with this, look around, and I'd like you to give me some idea of what these things might look like. So, and then I'll walk through it and just talk about. Actually, you know what? I'll walk through this with you guys. So, I said you could dynamically allocate an object, all right, using the new operator. But we don't always do this dynamically. You might actually create a person object right on the stack. So, draw this up here. So let's say we have our main function here. So if I do this, that is going to create an actual person object on the stack. Okay. Meaning that these variables would somehow represent a person object. Now, if I dynamically allocate it, chances are there will just be a single 4-byte value reserved on the stack for that object. Okay, because all we need is a pointer to the object. The operating system goes and makes memory somewhere else for us to put our information. So that means that this guy right here was created dynamically. So var38 is what?
Pointer.
Okay.
2 is the 1.
Okay.
As is 14. And the.
Say it again.
It looks like everything except var34 is a pointer.
Okay, and why are you suggesting that?
Because var34 is 20 bytes long, everything else is 4 bytes long. I think.
var34 is 20 bytes long.
Because it goes 38, 34, 14.
2 zeros.
Or sorry, is hex 20 bytes long?
Okay, so one thing I want to point out is that IDA isn't always right.
Well, if we drop that assumption, who knows?
Right, so IDA is purely basing these variables. It creates these because there was a reference to some offset. So let's see here. I'm gonna turn off. How about this? Okay, so let's take a look at var 8, for instance. Right now I'm going to change it to just I'm going to remove the local variable reference that IDA was sticking in here for me. What we really have is EBP minus 8. So remember, we enter the function, EBP is set up, so we're setting the base of the stack for this function. So all these things that say var 34, argv, all this stuff, those are just relative offsets to the base of the stack. So we've got this return from main. Then we've got this push EBP, so let's get it right here. And then we have what IDA refers to as var4. So we've got 0, 4, 8, positive 4, positive 8. So this is, what is this guy? argc. And what's the problem here? So the problem here is that IDA actually assumes, it has recognized this push EBP instruction. Okay? And even though the function, when we jumped to this function, when we enter here, the stack technically would be right here. This would be the stack pointer. We want this to be based according to where EBP is after we've moved ESP into EBP. Now we have -4, 4. Okay. So these variable names, they just represent some offset from this point in the stack. And so IDA is just giving a somewhat arbitrary name. var4 wasn't used in the code, okay? argc was used in the code, but that's because IDA understands it's a main function, and the signature for that main function is that the first item is argc and the next item is argv. Okay, so IDA is saying I saw some offset from EBP to -8. So I'm going to create a variable, and since it's 8 bytes off, I'm going to have an 8 at the end. And because it's negative, that says it's a local variable, so it puts this var underscore. Okay, so that's how IDA determines what name to place here. So, despite the fact that these look like individual variables that were created during the when this code was written, these actually could be members of a structure. So maybe I have a structure that goes from var 34 to var 4. And this code actually accesses individual members of this structure directly. So because it does that, it actually thinks these structure members are variables, which in essence they are, but they belong to a higher level object. Okay, so var 34 is loaded in the EAX. We push it just before string copy, and we copy Lisa into there. Okay? So, what might you surmise about var 34? It's a name? Okay. So, it could be a name. Alright, so just used elsewhere. It isn't. Okay. So we know this thing has some sort of a name. And Lisa is statically allocated. Okay. We also see Homer is used var 8. We're storing this Homer into var 8. Let's just take a look at this location here. Scroll down, we see a bunch of null bytes. Potentially, this name has a larger space than Homer will fill. Okay. See some sort of an integer. We see an offset to the name Marge. And from there, we see an offset to the name Bart. So there are two possibilities here. We could have, this could be a name pointer, or because we're seeing kind of so the space between the name here and Bart, 2C to 5,4. So subtract 5,4 from, or 2C from 5,4. Anybody do that math for me? Open up Calc. Is everybody familiar with the scientific version of Calc?
It's
actually, there's a programmer.
x28 decimal 40.
X28.
x28 decimal 40.
Okay. And what about the distance between Homer at 5,8 and
You say 5.8 or 5a?
5,8? And this pointer to Marge, 80. So we want 80 minus 5c, or 5,8, sorry. So this has actually changed since Windows XP, the calculator. Used to have scientific, and you could choose between hex, decimal, and so on. Now there's this programmer calculator.
28 again.
So right, you can do 80 minus 5,8.
Yeah. 28 or 22.
You're in decimal.
I'm in decimal.
Oh, there we go.
80 minus 5.
You typed 81,
Yeah, you typed
so
81,
that's
so
the same number. Others see.
As you can tell, I'm not used to this version. Okay, so 28. So you can, what I'm trying to point out here is that these things are, they look very, very similar in the way they're laid out in the memory. So where this could be a pointer to a string, it could also be a pointer to another object. You go back to main.
So one thing we don't see in main is the word Bart. So why is that?
That's a good question. Well, the reason why we see Homer here and Marge here is there's some sort of assignment, right? Apparently we maybe don't do anything with Bart, or we don't access them directly, right? Maybe we do it through some chain
Somewhere
of,
else in the structure.
right, exactly. So who can tell me how big our structure is?
I'd hazard it would be X.
I'll tell you, it's on the screen right in front of us right now.
2C.
2C. Okay? So our operator new, that's going to take in the size of the object that we want to create space for. Okay? So we can actually create a structure and call it person. So to get to here, we're going to do Shift F9, I believe. Shift F9. And then once we're in here, we hit Insert, type in a name. What I know is they're all Simpson characters, so why not call it Simpson? All right. And then we know that there's a name in there somewhere. Okay. So let's try, let's do ASCII. Okay. So if we press A, it's going to give us this struct field size. Okay. So this is allowing us to create some sort of an array. And right now, I know this thing is 2C bytes. So for now, I'm going to say the array size is 2C. Make sure you put an OX in front, OX2C. And there we have our structure. I'm going to give it a name. I just pressed N when I selected field 0. Label it name. Now let's explore a little bit more. Okay. So we have this person pointer. This is what came from our operator new. And I want to see how it's used. So here we've got it, we've moved it into EDX. And then we store it into var4. So we know that var4 is either another person pointer or it could be a string pointer. Now why do I say that? Okay, so right now, what we have defined, keep bringing this back over here. At the top of our structure, we have name. Right. Okay, so what is our person pointer pointing to?
0.
0 offset. So we could either be pointing at the object itself, or we could be pointing at the first item on the object. Okay. I'm going to call this name or person. And I'm going to stick with my convention of using a question mark because I don't really know.
Doesn't the object have the virtual function?
Oh, yeah.
Say that again?
Doesn't the object have the virtual function table at the beginning?
And what gave you that impression?
I thought you said that earlier. That's how functions work.
Well, that depends, okay? So, in what case will we actually have a virtual function pointer table at the beginning of our object?
Did you have to have inherited from something?
Right. So, it has to be inherited, Willie. So, in other words, it looks like that this person class is the end-all be-all. There's no child class. This is a base class. Okay, and it doesn't seem to have any inheritance.
I see.
Does that make sense?
Thank you.
No problem. Okay. So, we look down here. I had asked, well, is this thing a name or a person? Okay, you can see all the usages of this thing. And it's used over and over again here. We see it moved into ECX, and then we see some offset to it. Okay? So this tells us a couple things. First of all, we know this is a
Person pointers.
person pointer. Okay. And I can be a little bit more specific because I have an idea of which person it is. So who can tell me who this is?
It's Maggie.
Okay, so it is Maggie, and other than the fact that I see Maggie right on the screen right near here, we've got this called a string copy, okay? So we move the person pointer into EAX, but the person pointer also is a pointer to the name string, okay? So we're going to copy into the name this other parameter here, Maggie, and it's supposedly 32 bytes. So, and generally, when you call string copy, this value here, this third parameter, which is 32 bytes, that is the max size. So that I would generally say, I've allocated 32 bytes for this thing, so only write 32 bytes at the most. So I can go back to my structure here and change this. So I'm going to click on name within the structures window. I'm going to press A. I'm going to change this size now to 32. Or you can do hex 20. OX 20. Okay. And I see 3 different member accesses, okay? So we've got one at 20, one at 24, one at 28. So I'm going to go back to my structures window. I'm going to hit D 3 times after I click on the bottom Simpson here. Should end up with field 20. I'm going to click on the bottom Simpson here again, this end-s line. In fact, you can click on end-s. Press D 3 times. I'm going to do it one more time. And that gets us up to a size of 2C, which we said was the size of our structure. Okay. Now, what are these things? First of all, so I showed you yesterday, if you click on these structure offsets, if you press T, you'll be able to choose what structure offset we're dealing with here. And choose field 20. And note that this restricts it to anything that's 24 bytes from the base of the structure object, okay? So it gave me field 20 last time. This time I'm on EDX plus 24. It gives me field 24.
Is there a way to override that? Like if there's a pointer to the middle of the structure and you're doing offsets from that for some ungodly reason? Can you force IDA to say this is that field?
You might be able to create a stack variable.
Okay. Oh, that would work, yeah.
That makes sense. There could be an issue. You might be able to do that. But as far as another method, if that stack variable is already taken, that is something that you'll probably have to consult the item book or something. I don't know if that's there. I don't recall that being in there, but might want to check some other sources. So I've got all these different offsets, and right now I really don't know what they are, and this is not really helping me at all. We're moving 1 into field 20, we're moving 0 into field 24, we're moving 0 into 28. But using the information I have from before, I can actually at least sort out one of these things. So
Can we just use the breakpoints in the middle so we can see, okay, here's what ECX is, EDX is, and EAX is.
But Maggie's 1.
you could debug this. Sure, absolutely. Now this is taking a leap here, making assumptions. All right. So I'm assuming that when this message is printed out, Maggie is 1 year old. That is containing only information about this Maggie struct. So if that were the case, then what can you tell me about one of these items here?
Field 20 is age.
Okay, so field 20 is age. So we'll try that. So, but to clarify that, we'll dig further. Okay, we see these output messages we had. This might have been a good starting point. So you ran this thing, you saw its behavior, you wanted to understand why it printed out these messages. The first thing you might do is say, okay, well, where's printf? Where are these strings? And you can see we've got this output message here. Printf, some format string is blank years old. So we'd expect that offset 20 to be used for this %d here, right? And we'd expect the name offset to be used for this %s. So take a look above here. We have ECX plus 20. So there's what we said was our age offset. So hit T. age, and that kind of clears things up for us, so pretty confident that that's age. Now, we see var 8 here is going to be our object, okay? In fact, at the beginning here, we moved Homer into var 8. So, I'm going to call this guy Homer. var 8 is now Homer. And we got his age. And then this other push before our printf here, got this %s. Okay, that's going to be the name. But why can't I give this thing an offset? Well, that's a problem with the way. So right here we're getting the base of the object. Okay. Now next thing you'd expect is to reference some offset from that base, but since the name is actually at the base, you don't actually have that +0. So as far as trying to force this,
You can do a manual.
you can do a manual. So I don't know if you're able to actually, when you do manual,
Online.
you're able to do a manual here?
Yeah,
Oh, you're
on the
saying
line above there.
Oh, line
Yeah.
above, okay. So what you can do here, instead of actually using this Simpson.age offset thing, you can actually put name here or Homer.name. So when you can't use this like the structure offset feature or one of the other features for that matter, when they're not available to you, go ahead and try using a comment. And I use the semicolon to do that. Semicolon will give you this dialog, type in your comment, and click OK. So, once I've done that, I now come over to this line of code, moving Homer into ECX, and I'm getting this offset 24. Now that's one we haven't figured out yet. It's going to just show up as Simpson.field24. I'm comparing that with 0. If it's 0, I'm going to come to the right. And if it's not 0, I'm going to come to the left here. Now once again, I take the Homer pointer. I get offset 24 again. And now I'm going to push that onto this call here. So I've got 2 pushes and is married to %s. So what do you think, what would you call this field 24?
Spouse. Who is married to.
Right. So this is a spouse pointer.
And by 0, it really means null, right?
Right. So if they didn't have a spouse, then we wouldn't output. So what we've got here now is we've got this loop. We're printing out each person. And if they're married, then we go ahead and print out this. Otherwise, we're going to go to this side here and skip the spouse. And then we go ahead and get offset 28, and we start the loop all over again. So rather than calling this Homer, what would be a more accurate name for this pointer?
Person, or Simpson, or
Person, okay, or current. So it's in a loop, and it's referencing the current object we're concerned with.
Simpson family member.
Right. Okay, so what would you call this last offset then? If we're going through this list and we change the current pointer, right? So it's basically a linked list of people. So shift F9 again. We're going to name this thing next. So maybe a better name for this would be person node. So that's how you create structures and apply their member names. Any questions?
Yeah, how do you apply structures to the data like we did? I think we did that yesterday, but I'm trying to do it here,
Okay.
and it won't let me.
Good question. So once you've created your structure definition, you may actually want to apply it to memory. So I'm going to go to the very top of the main function. I'm going to click on this offset to Homer. And if I right-click here, I don't have the option to define a structure, so I'm going to have to just remember that Alt-Q allows me to define a structure type. And you see we have a person node here. Did that work for you?
LQ, yeah.
Alt-Q. And yes, I'd like to directly convert that to a structure. And I could do the same thing for the next person. We've got Marge here. Click on Marge, Alt-Q, find that as a person. And I can do the same for Bart. All right.
Hey, Matthew.
So,
If
yeah.
your person had
Sorry.
a method attached to it, would there just be a pointer back from the data segment back to the text segment for the code for that method?
Bill, can we turn up the volume? Is that possible?
Can you hear me better now?
Yeah.
Okay, I was wondering if the object had a method, would there just be a pointer back from the data section where the object is residing back to the text segment for the code for that method?
Okay, it's dependent on, so you always pass in the object pointer. So for instance, you pass it in using the, I showed you this pointer. Okay, so how about this? We're actually going to see this in the next example. In fact, we've got, the last thing we're going to do today is look at the file that I dropped. And I'm going to walk over that briefly, and that's one of the things I'm going to cover is what a function call looks like for a member. And then after that, I'm going to have you guys go ahead and try to figure out the class definition, or the class definitions for that were used to build the dropped executable. So go ahead and take a break until 2:30, and then we'll go over that, okay?